Okay, so part 2 of our stoichiometry lecture. Let's talk about chemical formulas and the mole concept. So chemical formulas can be interpreted in two ways. For example, N2O4. First way of interpretation, the formula N2O4 contains two atoms of nitrogen and four atoms of oxygen in one molecule of N2O4. Second interpretation, the formula of N2O4 contains 2 moles of nitrogen atoms and 4 moles of oxygen atoms, which are present in 1 mole of of N2O4. So basically, so first interpretation, we're just focusing on the number of atoms in one, or rather in the compound. So dito, ang inaano natin, or rather ang tinitingnan natin is yung atoms, whereas in the second interpretation, we're considering that each mole or each element contributes a certain number of moles in oxygen, or rather in the whole molecule. So sinasabi natin dito na meron tayong 1 mole ng N2O4, tapos meron tayong 2 moles ng nitrogen, and then 4 moles ng oxygen. Okay, so again, two ways to interpret chemical formulas. Okay, when it is necessary to know the number of moles of a particular element within a compound, the subscript of that element symbol is in the chemical formula becomes part of the conversion factor. So, in this case, para makapag-convert tayo or para malaman natin kung ilang moles of an element ang present sa isang compound, we use the subscript. Okay, for the formula N2O4, ganyan yung interpretation niya. For nitrogen, meron tayong 2 moles of nitrogen atoms and 1 mole of N2O4. Or 1 mole of N2O4 is equivalent to 2 moles of nitrogen. Now, saan natin nakuha yung 2? Kinuha natin siya again sa subscript. Okay? Kapag naman oxygen, you have 4 moles of oxygen atoms in 1 mole of N2O4. So naman natin kinuha yung 4 dito sa subscript ng oxygen. Okay? If you want to convert from if you want to convert or if you want to know how much of a certain element is in one compound, you have to use the subscript. Now, sample problem, how many moles of carbon atoms, hydrogen atoms, and oxygen atoms are present in 1.2 moles or 1.2 mole of C3H6O3? You have 3.6 moles of carbon atoms, 7.2 moles of hydrogen atoms, and 3.6 moles of oxygen atoms. Now, paano po natin nakuha yan? We simply equate 1.2, sorry, 1.2, and then use the conversion factor for each of the elements. So since tatlo po yung hinahanap natin, tatlong conversion factor din siya. So we want to convert 1.2 mole of C3H6O3. So we simply have 1 here, sorry, 1. And then kung ilan man yung carbon atom. So since we have 3 carbon atoms, that would equate to 3.6. And so on and so forth. So since we have 6H or 6 hydrogen atoms, that would convert to A7.2. And then since we have 3 oxygen atoms as well, you have 3.6 moles of oxygen atoms. Okay, so since tatlo po yung hinahanap natin, tatlong conversion factor din yung gagamitin natin. 3 times din po tayo mag-compute. Now, this is just a guide of of conversion factors. Now, kapag particles of a substance ang given sa'yo, yung conversion factor mo ay gagamit ng Avogadro's number. Kapag naman grams of substance ang given sa'yo, and then you want to convert to moles of substance, gagamit tayo ng molar mass. Kapag naman moles of compound ang meron tayo, and then you want to know the moles of element within the compound, gagamit tayo ng yung ginamit natin kanina, formula subscripts. Okay, so this is just a guide for chemical calculations. Okay, now this is another guide for computing for different substances or units. So, for example, you're given particles of A, and then you want to convert it to moles of A. Gamit lang tayo ng Avogadro's number. Okay, back and forth lang yan, and then it depends on how you set it up kung paano mo siya i-convert. So, for example, you want to convert particles of A to moles of A. Gagamit lang tayo ng Avogadro's number, but this time yung Avogadro's number ay nasa taas instead of nasa baba. Para ma-cancel out natin, or sorry, nasa baba pala yung Avogadro's number para ma-cancel out natin si particles of A. Okay, basta tandaan nyo lang, whichever unit you want to cancel should be used as the denominator para ma-cancel out natin yung original unit and then ma-convert natin to the desired unit. Okay, so just follow this map para hindi kayo mahirapan. There would be computations that, for example, you're starting from particles of A and then you have to get particles of B. In this case, gagamit kayo ng formula subscripts para mag-convert from A to B. Okay, and then all the rest are simple conversions lang naman. Okay, so I'd like to make a written video or a document video para mabigyan kayo ng example ng computations. Okay, next, yung sample problems natin. For example, vitamin C has the formula C6H8O6. Calculate the number of vitamin C molecules present in a 0.250 gram of pure vitamin C. So, very simple computation lang naman to. Ano na kailangan natin is, of course, yung given natin na 0.250 gram of pure vitamin C. And then, i-convert lang natin siya the number of vitamin C molecules. So, simple lang. Paano natin i-convert ang grams to number of molecules? Simple. Just convert your grams first. Convert natin siya to moles. And then convert natin si moles to molecules or particles. Okay, so yan lang yung map natin. And if you do that, ang makukuha nyo na is, of course, the answer. Next is how many grams of nitrogen present in 0.10 gram of caffeine. The formula of caffeine is C8H10 and 4O2. And next, how many grams of oxygen are present in a 0.10 gram sample of adrenaline? And the formula for adrenaline is C9H10 and O3. Okay, so let's just have this as an activity para makita ko rin or ma-assess ko rin kung gaano na ba yung understanding niyo for stoichiometry. So, I'm going to add a assignment submission page para dito. And then, i-convert nyo lang or rather, gawin nyo lang yung sample problems and then I'll check it para malaman natin kung paano natin i-approach yung stoichiometry. By the way, stoichiometry again is a heavy topic to grasp. So don't worry kapag hindi nyo agad nakuha yung computation on the first try. Definitely will have to polish it too. Okay, so writing and balancing chemical equations. Now this is also very important when we're dealing with chemical equations and and stoichiometry. Kasi before you can use the chemical equations for computations, kailangan balance muna sila. This has to follow the law of conservation of matter. Ibig sabihin, if two chemicals react, hindi pwedeng yung reactant natin or rather yung product natin mabawasan, hindi na naman pwedeng yung reactant natin kulangin. So, whatever your reactant is, yun din yung ilalabas ng product natin. Now, conventions used in writing chemical equations. These are conventions only, no? So these are not necessarily set practices. Okay, so reactants are always written on the left side of the equation, and products are always written on the right side of the equation. So kapag sinabi nating reactants, nasa left side. Kapag sinabi nating products, nasa right side siya ng equation. Okay, so these are your reactants, and then these are your products. Now the reactants and the products are separated by an arrow pointing towards the product, and then plus signs are used to separate different reactants and different products. Okay, so we have two different reactants here, and we have two different products here. Now makikita nyo, these are balance equations. So ibig sabihin, kung ilan yung S dito or ilan yung sulfur sa left side, ganun kadami din yung sulfur sa right side. So hindi siya pwedeng sumobra, hindi siya pwedeng kumulang. So if you have one atom of sulfur here, kailangan sa product, meron din siyang isang atom ng sulfur. A balanced chemical equation is a chemical equation that has the same number of atoms of each element involved in the reaction on each side of the equation. So sabi ko nga kanina, whatever is in the reactant side should always be on the product side. Hindi siya pwedeng kumulang, hindi siya pwedeng sumobra. Now, when we are balancing chemical equations, kailangan natin siyang i-balance through adding coefficients or by adding coefficients. Now, just a refresher, si coefficients yung mga numbers na nasa gilid ng ating molecular formula or chemical formula. No? Now, pakita na lang natin. So, yung mga highlighted numbers na yan, these are what is known or what are known as coefficients. Okay? Now, paano natin sila i-balance? Excuse me. Para ma-balance natin sila, we have to manipulate the coefficients. Now, guidelines. Again, these are just guidelines for you to follow and not specifically set rules, no? So, para lang mas mapadali yung balancing ng equation natin, let's start with the compound that contains the greatest number of atoms and focus on the element that has the greatest number of atoms. So, yung pinakamadami daw muna, yung kunin natin. Bilangin muna natin yung atoms. Sorry. Napindot. No. Let's count the different number of atoms muna. So, starting with Fe or iron iodide, meron tayong tatlong atoms. You have two molecules or two atoms of iodine and one atom of iron. So, next is chloride. Meron tayong dalawa lang, Cl2. And then you also have FeCl3. You have 4. One atom of iron and 3 atoms of chlorine. And then finally, you have iodine, which has 2 atoms. Okay, so sino daw yung may pinakamadami? Siyempre, si iron chloride, which has 4 atoms. And dito sa compound na to, sino yung may pinakamadaming number of atoms? Si chlorine. So, ang una nating ibabalance is si chlorine. Now, paano natin siya ibabalance? Siyempre, ang tulad ng sabi ko, maglalagay lang tayo ng coefficients. In this case, naglagay tayo ng 2 para maging 6 yung chlorine natin. And then dito naman sa reactant side, naglagay tayo ng 3 para maging 6 din yung chlorine natin. So, balance na siya. You have 6 atoms of chlorine on your right side and then 6 atoms of chlorine on your left side. Okay, so okay na tayo sa chlorine. Now, para dun sa second element naman natin, the one whose amount is already set on the side of the equation by a previously determined coefficient. So, sino daw yung naapektuhan nung pag-balance natin sa una? Ang naapektuhan dyan is yung iron natin. Since naglagay tayo ng coefficient na 2 dito, hindi lang naman si chlorine yung naapektuhan ng 2, pati si iron, naging 2 atoms din siya. So, next, ang ibabalance natin si iron. In this case, naglagay tayo ng coefficient na 2 because nadagdagan tayo dito sa first step natin. Nagkaroon ng 2 si iron. So, lalagyan din natin siya ng 2 doon sa reactant side. Okay? Next is to pick a third element to balance. You don't necessarily have to look for elements to balance since isa na lang naman yung natitira, iodine na lang. Since dun sa second step natin, naglagay tayo ng coefficient na to dito kay iron iodide, i-multiply natin yan sa subscript ng iodine. So magiging 4 yung total ng iodine natin dito sa reactant side. So we have to also add a coefficient of 2 on our product side. In this case, meron na tayong 4 and 4 on both sides. Meron na tayong balanced chemical equation. So, unang-una, binalance natin si chlorine, sunod si iron, and lastly, si iodine. Okay, so step by step yung pag-balance natin, mas madali at mas maayos ang process natin. Okay, so chemical equations naman in the mole concept. Like your chemical formula, there are two ways to interpret your chemical equations. No? So the coefficients in a balanced chemical equation can be interpreted also in two ways. So first is one molecule of N2 reacts with 3 molecules of H2 to produce 2 molecules of NH3. Now, you can also interpret it as 1 mole of N2 reacts with 3 moles of H2 to produce 2 moles of NH3. So same concept with the previous lecture. Dito ang naiba lang is instead of subscript yung ginagamit natin, ang ginagamit natin is yung coefficients. Okay? So next. Okay, so here is an example of chemical equations in the mole concept. Tandaan nyo lang guys, we have to first balance the chemical equation before we are able to use the coefficients for computations. Kasi kung hindi balance yung computations natin, hindi rin tayo makakagamit ng coefficients for computations. Okay, so in this case, meron tayong 4 moles of iron and then 3 moles of O2. Then yung product natin is 2 moles of iron oxide. So, nandito lang yung mole-to-mole relationships nila. And then finally, nandito yung conversion factors. Okay? Now, here is the same map. Ang pinagkaiba lang niya dito is gumagamit tayo ng equation coefficients instead of formula subscripts. So, pareho lang naman yung map niya. The only difference is mole-to-mole conversion instead of subscript yung ginagamit natin, equation coefficients. Okay, so, example. Sorry. Yung previous one, that is an example of a balancing formula. So, I can go back since I'm recording through PowerPoint, no? Anyways, limiting reactants or limiting reagents, excuse me, the reactant in a chemical reaction that limits the amount of product that can be formed. Then you have also the excess reactant in a chemical equation that remains when the limiting reactant is completely consumed. So, i-visualize natin yung limiting reactants. Okay, so in this case, meron tayong before reaction and after reaction. So kapag sinabi nating limiting reactants, siya yung nauubos agad. The limiting reactant is the reactant present in the smallest stoichiometric amount. Ibig sabihin, mauubos na siya or mako-consume na siya before mag-complete yung reaction. Ang matitira natin dito, in this case, is yung excess reactants natin. So these are your excess reactants, no? And then yung limiting reactants natin, in this case, is hydrogen. Since yung hydrogen natin naubos na agad, these are your limiting reactants. Meaning, hindi ka na pwedeng mag-produce ng water without more hydrogen atoms. Next is your percent yield. Now, the theoretical yield is the amount of product that can be produced based on the calculation. So, ito yung theory natin. Meaning, kapag nagko-compute kayo ng stoichiometry, and then nakapag-compute kayo ng yield, sabihin, for example, ang nakita nyo na dapat na yield is 20 grams, that is your theoretical yield if that is based on your computation. Now, this is different from your actual yield. Kasi yung actual yield natin could be less or more or less than your theoretical yield depending on the efficiency of your experiment. Kapag mas efficient yung experiment nyo, then you have a percent yield that is more than 100%, no? Kapag naman hindi masyadong efficient or maganda yung experiment nyo, you would have a percent yield that is lower than 100%. In real life, in your real experiments, hindi naman tayo nakakapag-produce ng 100% yield. Kadalasan, ang nakukuha natin dyan is around 60% to 90%, but again, that would depend on your method of experimentation. Your percent yield is a comparison of amount actually obtained versus the amount predicted. So, syempre, kapag ikaw ay may projection, for example, ikaw ay may business, syempre, alam mo na dapat or meron ka ng pag-aaral kung gaano kadami dapat yung makukuha mong sales for today. That is your theoretical yield. Ngayon, kapag yung mga kliyente mo naman na papasok for the same day, magbabayad sila, and then syempre, yung makukuha mo doon is what you call the actual yield. So, meron kang computed na theoretical yield, and then meron kang actual yield na actual na clients na pumasok at nagbayad. And if you compare that, that is called percent yield. So, ito yung formula. Very simple lang naman. Actual yield over theoretical yield times 100 is your percent yield. Okay, so another activity is limiting reactants. Pero after this, I'll show you the sample problems. Pero para makuha natin yung limiting reactants natin, number 1, convert the reactants from grams to moles, and then relate moles of reactant A to reactant B, and then relate moles of reactant B to reactant A. So basically, maghahanap lang tayo or i-relate lang natin yung dalawang reactants sa isa't isa para malaman natin kung sino dun sa dalawa yung limiting reactant natin. Okay? Now here is your sample problem. 114 grams of aluminum and 186 grams of fluorine ang given sa atin. And your questions are, letter A, what is the limiting reactant? Letter B, which reactant is in excess and how many grams of it are left? Letter C, how many grams of the product can be made? And letter D, if 200 grams of the product was measured after the experiment, determine the percent yield. So again, this is going to be part of your activity that is going to be uploaded in a while. So check nyo lang po yung canvas nyo for the submission page and the instructions for the activity. But please do answer this so we can assess kung ready na ba kayo for stoichiometric analysis. Okay, so I guess that's all for today. Thank you for listening, and I hope you learned something new. If you have any questions, you can message our Discord group chat para makita natin at masagot natin for the benefit of everyone. Okay, so guys, stay safe and bye-bye po muna.